Hi guys, welcome to Learn and Tribly. Today we are going to tell about transient analysis. Okay, what is transient analysis? It is a transient circuit in the temporary change and state of voltage and current takes place. For example, what is a transient period? If in a circuit, if there is a storage of elements in the energy or a storing of energy, now reacting over time is called transient period. For example, in the inductance and capacitors, storing of energy takes place. In a RC transient DC circuit, in this circuit, there is a voltage switch and then capacitor and resistors are connected. So here, electric field is calculated by field passing through the circuit and the field passing through between two parallel plates of the capacitor. So in 12th standard we will learn about E is equal to half CV square. This is the formula for calculating electric field in a given circuit. And and the basic knowledge is capacitance. What if capacitance connected in series? So it is opposite to resistance of parallel. If capacitance is connected in series, we should consider 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3 respectively. And if capacitance is connected in parallel, want to consider it as Cp and C1 plus C2 plus C3. These are connected in parallel. Next. And general formula for increasing and decreasing of exponential curve. So here instantaneous voltage, this is instantaneous voltage and final voltage is and the initial voltage has been given. So what is the general formula for calculating the increasing and decreasing of exponential curve? So increasing and decreasing of exponential curve can be calculated by the formula instantaneous voltage equal to final voltage plus open bracket initial voltage minus final voltage into e to the power minus t by tau. Here tau is time constant or torque. Similarly for instantaneous current. So instantaneous current is final current plus initial current minus final current into e to the power minus t power tau. And both it is in voltage and it is in amps. So Vf is final value and I is initial value and C is instantaneous value we are considering here. So what is time constant? So time constant is how fast and capacitor is charging or discharging is called time constant. So torque is equal to RC, that is resistance into capacitor. Torque is SI unit is seconds. So for example, charging of a capacitor. Charging of a capacitor is here at initially voltage will not pass through this since it is open switched. And capacitor is connected and resistance is connected. So initial current will be 0. So initial voltage also will be 0. VA equal to 0. This is so and final voltage. So Vf equal to Vs. So Vf equal to final current also will be Is and Vf equal to Vs. So finally, if switch is closed, so current passing through this capacitance and voltage passing through this capacitor and the voltage given as will be same at final value. This is called charging of capacitor. So here charging and discharging of curve can be given. Charging of curve. Charging of curve. Here charging of curve is to find the voltage and voltage passing in the current or voltage passing in the capacitor. So here charging of curve is voltage will given as this as the voltage. This is the curve passing in the charging of curve, and discharge in current it will be going like this. This is the curve we will get for charging and discharging of curve. So if we are substituting the value in a final initially, so we will get the formula, a general formula as in general formula. Initial voltage is 0. Actually, we are considering initial voltage as 0. This is the initial voltage we are considering, and instantaneous voltage equal to final voltage plus initial voltage is 0 minus final voltage into e to the power minus t tau. So here final voltage and initial voltage will be same. See, final voltage and instantaneous voltage will be same. So instantaneous voltage equal to Vs minus Vs, that is e to the power minus t by tau, and Vc equal to Vs, that is you are taking common voltage common you are taking, so Vs into e to the power minus t by tau, and that is in volts. So discharging of capacitor. Discharging of capacitor is nothing but when we are charging the capacitor and suddenly we are removing the switch, that is we are opening the switch. So this is called discharging of capacitor. Charge will be discharged from a capacitor, that is called discharging of capacitor. So after removing, the capacitor voltage will be same as of Vi. Initial voltage and capacitor voltage will be same, and final voltage will be 0 at last we are considering. So we are here, we will get the graph same. This is initial voltage, that is at highest portion, and finally we will get 0 here. This is final voltage, and here initial current is same, and the final will be 0 here. Both will be decreasing curve. For example, if we are going to this question, determine the capacitor voltage. In this question they are given, determine the capacitor voltage and current at 50 microsecond after switch is closed. If the capacitor is initially uncharged, sketch the charging voltage and current curves. So here we will get initial, first we are given initial voltage 50 voltage, that is given as initial voltage, that is Vi equal to 50 voltage. This is our initial voltage, and resistance given as 8200 ohms, and the capacitor is 0.01 millifarad. So here we want to find, first we want to find time constant, that is torque equal to RC. So RC equal to R into, that is 8200 into 0.01 millifarad, that is 1 into 10 to the power minus 5, because 0.01 is into 10 to the power minus 3 millis. So we will get 10 or else 8200 into 10 to the power minus 6 into 10. You can consider like this. So this is time constant. So 8200, that is, or directly we can take 1 into 10 to the power 5 minus 5. So we will get 8.2 into 10 to the power minus 2, or else 0.082 seconds. This is the second. This is a simplified form, so it will be easier to solve for us. Next we want to find the general formula. As of we know this, we want to find the charging voltage. As we know here we use charging capacitor here. Sorry. Here we know initial voltage is 0 and final voltage is 50. So 50 we will substitute directly in this formula. This is the formula we will substitute. So general formula is the general formula is Vc equal to Vf plus Vi minus Vf into e to the power minus t by tau. This is the formula we will get. So Vc equal to Vf is 50 plus Vi is 0 minus Vf is 50 into e to the power minus t divided by 0.082. This is the one we will get. So Vc equal to 50, we are taking common 50 minus 50 into e to the power minus t by 0.082. So we will take 50 as common. 1 minus e to the power minus t by 0.082. This is the instantaneous voltage. So after solving it in calculator, we will get as 1 second. So here we know that 1 divided by 0.082 you want to substitute. 1 divided by 0.082 will get us 12.195. So Vc equal to 50 into 1 minus 12.195 T minus. So we know that T is 50 microsecond in the question they are given. This is 50 microsecond in the question they are given. So Vc equal to 50 into 1 minus e to the power minus 12.195 into 50 into 10 to the power minus 6 microsecond. So if we substitute in calculator, 12 minus 12.195 is will get us 609.75. 609.75 if we solve it in substitute here. This is the instantaneous voltage you will get. So we can solve up to this. This is the last answer. And if they want an accurate answer, we can still further. But according to question, this is the final answer. And what is charging curve? We want to find the current curves here. So current curves here will be. Similarly, we can solve in initial voltage. But current curves here will be decreasing exponential curve because voltage here is increasing, so at current curves charging will be decreasing. So Vc by R we will get Vs by R, and here final voltage. So we will get here as decreasing curve, and this is torque. This is the current curve here. Thank you guys.